Hello everyone. Welcome back to the AWS Certified Solution Architect Associate Certification Bootcamp. In this module, we'll cover some important concepts around networking and optimization features in EC2, things that often appear in scenario-based questions. By end of this video, you will have a clear understanding on IP addressings in EC2. We'll explore private versus public IPs in EC2. Then we'll learn the role of elastic IPs. We'll explore different EC2 placement strategies and we'll cover cluster, spread, and partition placement. We'll also discuss the use cases, what is optimal for each placement strategy. We'll conclude this session after covering Elastic Network Interface or ENI, and we'll understand how ENIs provide networking flexibility to EC2 instances. Whether you are preparing for certification or building real-life solutions on AWS, this module will provide the necessary details in crisp and effective way. Let's dive in. We'll start with what is IP address. Think of an IP address like a phone number. It helps one computer find and talk to another one on a network. An IP address or Internet Protocol address is a unique number assigned to every device on a network like your computer, phone, or EC2 instances. It allows devices to send and receive information. There are two different types of IP addresses. First one is IPv4 or Internet Protocol version 4. These IP addresses are most widely used. IPv4 addresses are represented in 32-bit format, and it is written as 4 numbers separated by dot. For each number, you can have between 0 to 255 and then dot, again 0 to 255, again 0 to 255. So every 4 blocks can have between 0 to 255, and these blocks are called octet. We have about 4.3 billion unique IPv4 addresses. Since we have only 4.3 billion unique addresses, and with advancement of laptops, mobiles, and other networking devices, we are running out of IPv4 addresses. Then the solution is IPv6. IPv6 solves this by allowing many more addresses. IPv6 or Internet Protocol version 6. This is a newer version and it has 128-bit format. Here is an example. IPv6 addresses are written in hexadecimal and these are separated by colon compared to IPv4 where 4 blocks were separated by dots. Since this is 128-bit address, we have over 340 undecillion address, which is virtually unlimited. Now based on the routability of the address, IP addresses can be of two types. One is private IP and the second one is public IP. Now let's understand what is public versus private IP. We'll start with public IP. Public IPs are used for inside private networks, maybe inside your VPCs or local area network. Private IPs are not routable from internet. And here is an example. 10.0.0.5 or 192.168.1.1. These are private IP address examples. The most easy way to identify a private IP address is with the range or the IP range. Private IP address could be of 3 ranges. The first one is class A, where we have address between 10.0.0.0 to 10.255.255.255. If you pay attention, the last 3 octets that varies from 0 to 255, it supports over 16 million addresses, and class A private IPs are commonly used in large organizations. We have second type, which is called class B, and class B private IP ranges could be 172.16.0.0 to 172.31.255.255. Class B IP addresses supports about 1 million IP addresses That is why it is often used in mid-size network. And the third IP address range is class C, where the IP address can vary between 192.168.0.02, 192.168.255.255, and here you can see only the last two octets are varies from 0 to 255. That is why we have up to 65,536 addresses. This is not a very big number in IP ranges. That is why it is commonly used in home network. Apart from these IP ranges, if you see any other IP, those are all public IPs. Now public IP, that is used for any internet facing resources, and that is why it is routable from internet, and one example could be 3.88.25.74. Now for you to easily understand the difference between private IP and public IP, private IPs are like internal extension of an office. They allow devices to talk within a building or network, whereas public IPs are like a main office phone number which can be dialed from outside. You must be thinking, why does it matter for EC2 instances? Because when you launch an EC2 instance, it's always get at least one private IP. And this private IP is used for internal communication within your VPC or virtual private cloud. Private IPs are static and they don't change. Even if you restart your EC2 instance, then also the private IP will not be changed and it will be constant. On the other hand, you can optionally assign a public IP so that your instance can be accessed from outside. And to get a public IP, your instance must be launched in a public subnet, or you must enable auto assign public IP. If both the conditions are matched, then AWS will give a public IP address, and here is an example for that, and that allows internet access via internet gateway. Public IPs are dynamic and they changes every time the instance is stopped and started. Now let's go back to AWS Management Console and let's review this in action. I have logged into AWS Management Console and I am at EC2 instance dashboard. Here I have one EC2 instance that is already running. Now let's review the private and the public IP addresses. If we select this instance, I'll pull this bar up and here is the private IP address. The private IP address is 172.31.19.189. Let's copy this. And this is the public IP address of this EC2 instance, which is 54.167.58.94. Let's copy the public IP as well. And please remember this IP address. Now next, we are going to restart this EC2 instance. For restart, I'll select the EC2 instance, I'll go to instance state and then I'll stop the instance. I'll click stop. Now it is successfully initiated stopping. Let's wait for a minute for the instance to be stopped. The EC2 instance stopped successfully. It took about 30 seconds. And now it is in stop status. You can see the private IP still remains same, 172.31.19.189. However, the public IP is vanished. Now let's restart this EC2 instance. The instance is already selected. I'll go to instance state and I'll start instance. Maybe I'll close these pop-ups. And now let's allow it another 30 seconds to 1 minute for the instance to be started successfully. My EC2 instance is ready now. The current instance state is running. And here is the private IP. The private IP is 172.31.19.189. It's still the same. However, the public IP is replaced with a new IP. The current public IP is 44.222.206.51. The previous IP was 54.167.58.94. You can see if you will restart your EC2 instance, it will always get a new public IPv4 address. And this is the reason why we don't use public IPs for anything persistent with EC2. To solve this problem, AWS provides a service called Elastic IP, And that is what we need if we need a consistent public IP address. Now let's review Elastic IP. An Elastic IP is a static public IPv4 address that you allocate to your AWS account. You can associate with an EC2 instance and then reattach to another one instance if needed. And this solves the problem of losing a public IP when you restart an instance. An Elastic IP address is static and it does not change over time, even if you restart your EC2 instance. An Elastic IP address is for use in a specific AWS region only, and you cannot move this IP address to a different AWS region. An Elastic IP comes from Amazon's pool of IPv4 address or from a custom IPv4 address pool that you can bought to your AWS account, like bring your own license. This is called bring your own IP. Please remember, AWS does not support Elastic IP for IPv6. Elastic IP is available only for IPv4. When you associate an Elastic IP address with an EC2 instance that already has a public IPv4 address, for our case, let's assume we have one EC2 instance and the current public IP address is 3.54.67.128, and you have provisioned one Elastic IP and the public IP for that Elastic IP is 23.14.87.120. And when you attach this Elastic IP with your EC2 instance, the existing public IP will be released to Amazon's public IP pool. And the EC2 instance will get the Elastic IP's IP address as its own public IP. By default, all AWS accounts have a quota of 5 Elastic IP address per region because public IPv4 internet address are very limited and it is a soft limit. If you need more IPs, you can always request to AWS support to increase that limit for your account. There is a charge for all Elastic IP addresses, whether they are in use, that means it is allocated to a resource like EC2, or it is idle. Compared to 2-3 years back, the Elastic IP was only charged when it was idle or not associated with an EC2 instance. But as of now, any Elastic IP you will provision in your AWS account is chargeable and AWS will charge you per Elastic IP. Now let's review Elastic IP in action. Back to my EC2 dashboard. From the left hand side, you can locate Elastic IP under Network and Security, and Elastic IP is the second option. Let's click Elastic IP. I do not have any Elastic IP as of now. If you are following with me, please remember AWS will charge you once you provision an Elastic IP. If you don't want to get any charge, you can just see me doing this exercise. Now let's allocate one Elastic IP address. For that, I'll click the Allocate Elastic IP. I want to allocate public IPv4 address and network broader group. This is UST1, and I am going to get that from Amazon's pool of IPv4 address. Now let's allocate. Here you go. I got one Elastic IP. You can optionally add one name. Maybe I'll use the name as CS or CloudExpert Solution Elastic IP. Now I can attach this Elastic IP with my EC2 instance. Now let's go back to EC2 dashboard. Now let's review the public IP address that is already associated with the EC2 instance and which came when we launched that EC2 instance, or for our case we restarted the EC2 instance, and second time when you start that EC2 instance we got this public IP. This is 44.222.206.51. Now let's again go back to Elastic IP, select this IP address. From action, let's associate Elastic IP address. You can associate that Elastic IP with an instance or with a network interface. I am going to associate with an instance. Instance is selected by default. Now from the drop down, I can choose the instance. I have already one instance. I have selected. I don't want any private IP address. Now let's associate. I have successfully associated this Elastic IP with an EC2 instance. That is why I can see that allocation ID. Now let's go back to our EC2 instance and we'll see the EC2 instance IP address will be replaced and this will be the EC2 instance new IP address. I'll go back to the instances or instance dashboard. If we select and let's refresh this instance, here you go. You can see the public IPv4 address has been replaced and currently it is 3.224.122.255. Previously it was 44.222.206.51. Now let's restart this EC2 instance one more time to check if the public IPv4 address is going to change or not. I'll go to instance state and I'll stop. I'll wait for the instance to be stopped. Okay, the instance is stopped successfully. That is why the instance state is stopped. Let's select. The private IP is remain the same. The public IP is also the same since we have stopped. Now let's start this instance and let's monitor the public IP. I'll go to instance state and start instance. I'll close these pop-ups again. Okay, the instance bounced back successfully. The current status is running and all the status check passed. Now if I select that instance and come to detail, here is my public IP address and the public IP address is still remain the same, 3.224.122.255, and the private IP is again the same. Now we saw if you want to retain a public IP for our EC2 instance, the only way is we have to use Elastic IP. However, using Elastic IP is not a good architectural design unless and until you have a legacy application and must use static IP. But if you have an option, we should try to avoid Elastic IP. There are multiple alternative ways to avoid Elastic IP. One of them could be we can use a DNS and we can register that EC2 instance with a DNS and we can use the DNS name. Or the other alternative could be we can use a load balancer. We are going to cover load balancer in our next module. So we are going to explain everything how you can avoid Elastic IP and you can get a stable application without an Elastic IP or fixed public IP. Our next stop is placement group. An EC2 placement group is a logical grouping of instances within AWS. It controls how EC2 instances are placed on the underlying hardware to meet high performance, high availability, and fault isolation. Think of a placement group like seating arrangement at a wedding where some guests should sit closely, that means they should have low latency, and some far apart, that means they are fault isolated, and others in balance section. Placement groups are AWS's way to optimize instance seating. And why should we use that? Because it helps you optimize low network latency, high network throughput, and high fault tolerance. AWS offers 3 different placement groups depending on your needs of performance, availability, or both. They are cluster, spread, and partition. Now let's explore one by one. We'll start with cluster placement group. Cluster placement group are like putting servers next to each other in a single availability zone. Here is a diagram of cluster placement group. You can see all the EC2 instances belongs to one rack space. Definitely they are in a same availability zone. And they can talk extremely fast and provides lowest network latency and highest throughput. Since you are trying to place the instances in a single rack, AWS recommends to use single launch request for all the instances in the placement group, and all the instances must be homogeneous. That means all should be either Linux instance or Windows instance, or all from the same instance family like burstable or compute optimized, and definitely the same size. If you try to add more instances to the existing placement group, you might see insufficient capacity error. That is because the rack space does not have enough hardware to support the new instance. And if you receive a capacity error when launching an instance in an existing placement group that is already running, you should stop all the instances in the placement group and then launch again. If you will restart this placement group, the instances might migrate to a different hardware where they will have capacity to run the entire group. Cluster placement group is best when you have use cases like high performance computing, big data application, machine learning training, and network intensive applications. However, there are risks because that is limited to one availability zone, and it will increase the failure risk if the availability zone goes down or if the entire rack space goes down. The entire placement can fall if the capacity is low. Now, to solve this fault tolerance or the fault isolation, we have the second type, which is called spread placement group. Spread placement groups are like putting your important people in different rooms such that if one room collapsed, the others are safe. To mimic this behavior, in spread placement group, instances are placed on separate physical hardware. And here is a diagram. You can see they are spread across availability zones, and even within an availability zone, one EC2 instance will be in one rack space. That is why you have a maximum limit here. You can run a maximum of 7 running instances per availability zone. For example, in a region with 3 availability zones, you can run a total of 21 instances in that group. And if you try to add one more instance, that is your 22nd instance in the group or 8th instance in an availability zone, then your instance will not launch. Spread placement group minimizes the failure risk and it provides highest level of fault tolerance. It provides built-in high availability as it works across multiple availability zones. In terms of risk, you can run limited number of instances in your placement group and limited to 7 instances per availability zone. This is obviously not for any large-scale batch workload, and it is slower in network because they are all launched in different availability zones and in different rack space. That is why in terms of the network bandwidth or the network speed will be definitely less than cluster placement group. In the previous 2 slides, we reviewed cluster placement group where we achieved very low latency. However, they are not fault tolerant. On the other hand, with spread placement group, we can minimize the risk and maximize the fault isolation. But if you have a workload which requires something in between, as an example, if you have a big data system like Hadoop or a Cassandra database, we need more nodes, and if we lose one node or even losing a rack, it should not crash the workload. To solve this problem, we have the third category, that is partition placement group. In partition placement group, instances divide into logical partitions. Each partition is on a distinct hardware, that means in a rack with power and network. Here is an example. Compared to spread placement group, here we have 3 availability zones, but under one availability zone, all the instances belongs to one rack space rather than spreading across rack spaces. By this way, we can isolate the fault to a single partition. If one partition will go away or if one partition is down, still we have 2 partitions and we'll get the highest bandwidth and the fault tolerance. This is ideal for any large clusters that supports thousands of instances. These provide visibility into which instance in which partition. In terms of use cases, you can use partition placement group for Hadoop, HDFS or Cassandra-like workload. You can also use for big data and analytics workload. You can use if you have a distributed fault tolerance system requirement. In terms of risk, this partition placement group is very complex to design, and this is not ideal if you have a use case with ultra low latency communication between the nodes. then you cannot choose placement partition group. Here is a quick comparison between the placement groups. This is the diagrammatic representation of every placement group. Now in terms of network performance, cluster will provide highest network performance, spread will provide moderate, whereas partition placement group will provide a balance between that two. When it comes to high availability, cluster will have the lowest high availability, spread has high, and also partition will have high. In terms of fault isolation, cluster will have the lowest, where spread will have very high fault isolation. And since in partition placement group, if one availability zone will go down, you will lose a chunk of cluster. However, you can still run your application with the remaining availability zones. That is why the fault isolation is high. And in terms of max instances, for cluster, it depends on the cluster capacity based on the rack space. For spread, you are limited to 7 instances per availability zone. And for partition, it's thousands. There is no limit. In terms of use cases, you can use cluster partition group if you have a HPC or machine learning workload. Spread is ideal for critical applications, whereas partition placement group is ideal for big data or HDFS. Now let's go back to AWS Management Console and let's review how you can create a placement group. Back to my AWS Management Console and I am at EC2 dashboard. Now for this, I am going to launch a new instance. I am not going to add any name tag. I'll choose the default operating system, Amazon Linux. I'll choose the default AMI. Instance type is also default for me. I'm not going to choose any key pair because I'm not going to log into this EC2 instance. Now in the networking settings, if you remember, this is the auto assign public IP. If you have enabled, then only you will get a public IP. Now I'll go to advanced detail. Let's expand the detail. And if you scroll at the middle of the screen, you will see the placement group. Here you can select a placement group, but before that you need to create a new placement group. Let's create a new placement group. You can create placement group. You can provide a name. I'll choose the name CES Demo Placement Group. You can choose whatever the name you want. Now here is the placement strategy. Either you can choose cluster, spread or partition. I'll choose cluster and then I can create group. I have already created that placement group. Now let's go back to the EC2 instance and let's refresh. Here I should select the placement group. Now if I launch this instance, it will be placed in that placement group. Now if I launch more than one instances, if I select let's say 10 instances here, all the 10 instances will be launched in this partition group. That means they will be in the same hardware or same rack space. I don't have an use case. That is why I am not going to launch this instance. I'll cancel. Now let's talk about Elastic Network Interface or ENI. Elastic Network Interface or ENI is a virtual network card, and every EC2 instance gets a default network card or primary ENI. When you launch an EC2 instance, it comes with a primary ENI where you have the primary IP. But you can attach a secondary ENI as well with your EC2 instance. And let's assume that I have created this ENI and I can attach this with my EC2 instance. You must be asking, why should I attach the secondary ENI? Because this is useful when you need more flexibility or multi-homing or multiple IP addresses for your EC2 instance. Every ENI will come with a private IP address, with a public IP address, associated security group, and a MAC address. Now you can move this ENI between instances. If we assume that I have a second EC2 instance, and if we want to move this ENI, I'll be able to move this ENI from EC2 instance 1 to EC2 instance 2. This is helpful when you want to implement a failover architecture for your network appliances or for your EC2 instances. Now please remember, ENIs are bound to a specific availability zone. Let me clarify. If you have created an ENI for one availability zone, then it must be attached with the EC2 instance launched in the same availability zone. and you can't attach it with an EC2 instance that is launched in a different availability zone. As an example of that failover, let's assume that you have monitoring agent that you want to retain its IP even if the instance is failed. In this example, I have two EC2 instances, and let's assume my monitoring agent is running on this EC2 instance. And if I have high availability setup for that EC2 instance, if this EC2 instance will be crashed, a new EC2 instance will be automatically launched into a different availability zone. Now you can automatically detach that ENI from that old EC2 instance and you can attach it with the new EC2 instance. By this way, you can create fault tolerant architecture if you have a requirement. Now let's go back to AWS Management Console and let's see ENI in action. Back to my AWS Management Console. You can locate ENI from left hand side under Network and Security. The last option is Network Interfaces. Now let's click this and let's create a network interface. The description is optional, but to identify I'll use CS demo ENI. You can choose whatever the name you want. Now here I have subnet. Before creating a ENI, let's go back to EC2 and let's see in which availability zone my EC2 instance is. I'll go to EC2, instance running. And for my EC2, it is running in US East 1A. That is why I have to create that ENI into US East 1A. I'll go back to network interface. I'll create one. Again, I'll provide the same name. I'll choose the subnet which belongs to US East 1A. Here you can either assign that private IPv4, either you can go with auto assign or you can use a custom. And if you use custom, you can provide whatever the IPv4 address you want. I'll go with auto assign. Now here is the security group. Which security group you want to attach with this? I'll select any one. From advanced detail, you can assign IPv4 prefix delegation. I don't want to assign that. Tagging is optional. I am going to create network interface. This is the ENI that we have created. Here is our description, CS demo ENI. Now I can select and I can attach this with my EC2 instance. I'll select the VPC first and then I'll select the EC2 instance and then I'm going to attach this. Here you can see I have this ENI that is attached. This is the ENI that it came when the instance is launched. That means this is the primary ENI. And the ENI that we have launched now, that becomes the secondary ENI. Now let's go back to EC2 instance and let's see. Now let's select this EC2 instance and here you go. I have now two private IPv4 addresses. One IPv4 address, the 19.172.31.19.189 that came from the primary ENI. And the second one, it came from the secondary ENI, what we have created. Now let's review these two addresses. If I'll go to network interface, the first one that we have created just now as part of this demo, and the second one it created by default when you launch this EC2 instance. Now it's time for cleanup. If you have already followed with me, now let's first terminate that EC2 instance. Then we are going to deallocate the elastic IP and this network interface. So first we'll go to instance. Maybe I'll select this instance. I'll go action, networking, detach network interface, and I am going to select the secondary one, detach. If I'll refresh, yes, one private IP has gone. Now I'll select, I'll go to instance state, terminate instance. I'll close all these pop-ups. I'll refresh, close this filter. It is shutting down. Now I'll go to elastic IP under network and security. We need to wait for the EC2 instance to be terminated. It's terminated now. Now I can select the elastic IP and release the IP. I'm getting some error. I found this very common. It can take a couple of minutes for the disassociation status to be reflected. I'll not elongate this video and wait for the deassociation to be completed. That wraps up this module. If you found this video helpful, Please give it a thumbs up and subscribe for more AWS exam preparation courses and cloud certification bootcamps. Got questions or feedback? Drop them in the comment. We love to hear from you. Thanks for learning with us at CloudExpert Solutions. You are now one step closer to crushing your exam. See you in the next module.